Morse code was invented to make long-distance communication faster and more practical in the early 19th century. Morse code was invented by Samuel Morse and Alfred Vail in the 1830s and 1840s. Samuel Morse, an American painter and inventor, developed the concept of using electrical pulses to send messages over a telegraph. Alfred Vail, his assistant and collaborator, helped refine the system and worked out much of the practical code structure. So while Morse's name is most associated with it, Vail played a key role in designing the actual code. With the invention of the electric telegraph, it became possible to send signals instantly over wires, but there needed to be a system to represent letters, numbers, and punctuation using simple electrical pulses. Morse code provided that system. Dots and dashes, short and long signals, could be sent over telegraph lines. It was simple, efficient, and easy to learn, making it ideal for operators. Together, Morse and Vail changed the world. Morse code laid the groundwork for modern communication systems, from the telegraph to the telephone and the Internet, revolutionized news, business, and emergency communication. Morse code, still used today in amateur radio and aviation communications. In short, Morse code was invented to turn the telegraph into a practical communication tool for everyday use. Morse and Vail designed the code so that the most common letters in English, like E, T, A, O, and N, have the shortest codes. For example, E is just one dot. Less common letters, like Q or Z, have longer sequences. This makes sending messages quicker and more efficient. As I go through the alphabet, see if you can hear the differences in the pattern of dots and dashes.
A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z.
At first, it might be hard to differentiate between dots and dashes. Human decoding in amateur radio refers to the process by which a person interprets and understands a received radio signal, particularly those that are transmitted as audible tones. In this next section, I will discuss 5 areas that will assist beginners in developing solid Morse code skills. Morse code is fundamentally an auditory language. Before sending code effectively, an operator must be able to decode rhythm and tone patterns by ear, almost like recognizing a melody. Developing listening skills helps the operator build the mental reflexes that make Morse second nature. Morse operators need to learn pattern recognition. The brain learns to instantly recognize tone patterns with letters or words, improving decoding accuracy and speed. This reduces mental fatigue. As listening becomes automatic, the operator can focus on meaning rather than sound. This promotes better situational awareness. Skilled listening allows an operator to copy weak or fading signals during poor propagation or interference. Head copying is also a critical skill. Eventually, operators can copy in their head, understanding words without writing them down. This is a mark of true fluency. Clear, rhythmic sending is just as vital as decoding. A Morse operator's fist, their unique sending style, defines how readable their signal is to others. Poor timing leads to confusion and missed contacts. Part of skill development is communication clarity. Precise timing ratio for dots, dashes, and spaces ensures that each character is easily recognizable. Smooth, consistent sending minimizes misinterpretation and improves QSO flow. Use a keyer, paddle, or straight key to develop rhythm. Record and review your sending to check spacing and tempo. Focus on sending clean, not fast. Consistency beats speed every time. This leads to confidence building. Practicing proper sending techniques makes operators more comfortable during contests or DX work. The term DX stands for distance or distance station. It refers to making long-distance radio contacts, often across countries or continents. The term comes from telegraph shorthand, where DX meant distance. Learning correct CW procedures, abbreviations, and Q codes transforms a beginner into a confident on-air communicator. CW has its own language and etiquette. Mastering it ensures a smoother, faster QSO. Using consistent pro signs like AR for the end of a message and abbreviations like OM, TNX, 73 keeps communication efficient. Familiarity with Q codes like QTH, QSL, QRS reduces word count and increases understanding across languages. Joining CW nets or contests builds practical skill under live conditions. The best kind of learning. After mastering the basics, advancing to higher speeds and more efficient decoding turns Morse into a natural mental process. This is where Morse begins to feel effortless and truly enjoyable. Koch and Farnsworth are two methods used to build speed without developing bad habits. Koch teaches characters at full speed from the start. Farnsworth spaces them for better comprehension. Head copying will become more natural. The idea is to listen to words rather than letters. This improves speed, comprehension, and endurance during long sessions. Participating in Morse code QSOs sharpens skills beyond what software can offer because every signal and operator is unique. A QSO, pronounced QSO, is the term used for a two-way communication or contact between two radio operators. It comes from the Q code QSO, which means can you communicate with me or I can communicate with you. Even skilled operators are limited by their hardware. Well-adjusted radios, clear audio, and proper antenna systems improve signal readability and operator focus. Proper side tone pitch, around 600 to 800 Hz, helps the ear detect signals without strain. Well-tuned transmitters produce cleaner tones that are easier to copy at long distances. Narrow CW filters and low-noise antennas help operators isolate signals on crowded bands. Proper antenna tuning and power levels ensure power is used effectively. This is critical for QRP and DX communication. Operators should experiment with filter widths, side tone settings, and antenna tuners. Keep stations clean from electrical noise. Focus is on optimizing the environment as much as focusing on technique. Because I mentioned Q codes several times, let me explain them. Q codes are one of the most useful parts of Morse code communication. They were originally developed around 1909 for commercial and maritime radio telegraphy to shorten common phrases. Operators still use them widely, even in voice operations, because they make communication faster and universally understood regardless of language. Q codes are three-letter abbreviations, all starting with the letter Q, that represents standard questions or statements. Q codes speed up communication by replacing long sentences with short codes. This helps reduce errors under poor signal conditions. It creates a common language for operators worldwide. No translation needed. And Q codes help conserve bandwidth and time, which is critical during contests, DX, or emergencies. The focus now is on the equipment needed for Morse code operation. Obviously, the first piece of equipment is the radio. Most modern radios are equipped with a Morse key port. This also means the radio is programmed with the necessary controls to regulate and adjust the signal. You are looking at a Yaesu 891 multi-band high-frequency radio. The ports are labeled for the convenience of this discussion. Look for the key jack. This port is for the code key. This radio model does not have an internal antenna tuner, requiring a separate unit for this function. Many radio manufacturers are now building radios with internal antenna tuners. When using this radio, only two pieces of equipment need to be connected to the radio: the tuner and the Morse code key. But what kind of key? The straight key is the most traditional and simplest Morse key. It consists of a lever, often with a knob, that completes an electrical circuit when pressed down. Each press produces a dot or dash depending on how long the operator holds it. The operator taps or holds the lever to create the rhythm of dits and DAWs manually. Timing depends entirely on the user's hand coordination. The bug key is a mechanical keyer that automatically makes dots but requires the operator to make a dash manually. Moving the lever to one side starts a spring-driven pendulum that rapidly makes a series of dots automatically. Moving it the other way makes dashes by holding the contact closed. The iambic paddle, or dual lever paddle, uses two contacts. One side makes dots, the other makes dashes. It must be connected to an electronic keyer circuit, which generates perfectly timed elements automatically. Squeezing both paddles together alternates dots and dashes automatically, iambic mode. The operator only controls which side, or both paddles are pressed. Timing is handled by the keyer. The single lever paddle is similar to an iambic paddle, but with only one lever. It moves left for dots and right for dashes. Each side of the lever closes its own contact. The keyer still produces automatically timed elements, but one at a time. The keyer paddle with a built-in electronic keyer integrates paddles with built-in keyer electronics, sometimes even with a memory for CQ or contest macros. It is compact, efficient, and ideal for portable QRP operation. It has perfect element timing and repeatable macros. Keyboard and computer keyers use a digital CW interface. Computers or microcontrollers can key the transmitter electronically using a keyboard or digital interface. Ideal for automated contesting or logging. Produces flawless timing and speed control. By watching this video, you've just taken your first step into the fascinating world of Morse code, a language that connects generations of radio operators, explorers, and communicators across the globe. You've now learned the basic idea behind Morse code, a simple yet powerful method of communication built from just dots and dashes. Remember, every dot and dash is more than just a sound. It's a symbol of precision, patience, and practice. Morse code connects us to the earliest days of radio, and it still teaches discipline, focus, and precision today. I encourage you to give Morse code a try.